Well, in this video, guys, we will be looking at inverse functions, but we'll only look at one inverse function today, which is the inverse function of an exponential. Well, guys, I want you to put this in your mind and note it. When we talk about an inverse function in grade 12, we are usually talking about the reflection. Let me show you what I'm talking about. The reflection about the line y is equals to x. So this reflection about the line y is equals to x remind us something like this. X of y, these are the coordinates. Then you will then swap or interchange. Where there is x, you replace it by y. Where there is y, you replace it by x. So we interchange. So inverse is about interchanging or swapping, right? The x coordinate and the y coordinate. That's what inverse function is about in grade 12, right? So when we talk about the inverse of an exponential, so today we are looking at exponential inverse. The inverse of an exponential, guys, I want you to note this. Inverse of an exponential, it's what we call a logarithm. It's a logarithm. Inverse of a logarithm is an exponential, so it's a vice versa situation. Inverse of a logarithm is an exponential. Inverse of an exponential, it's a logarithm, right? So it's very important that you note that, right? So basically in this video, I will be showing you how to sketch an exponential equation as well as drawing. Yes, we'll focus on that in this video, right? So without wasting time, let's get into it. Consider you're given let's say f of x, which is it's similar as y is equals to 2 to the power of x, right? So let's say you're given f of x, right? So you are required to determine the inverse. They will use this notation, f to the power of negative 1x. Determine to find the inverse in this form. You're required to find the inverse in this form. Remember, you'll be given like this. F of x is equals to 2 to the power of x. So if you want to find the inverse, where there is f of x, replace it by y. So you're going to say y is equals to 2 to the power of x. Remember, to find the inverse, we said inverse is all about swapping. You swap your coordinates, right? In this case, we'll swap our variables. So remember, where there is y, you are going to replace it by x, and where there's x, you're going to replace it by y. So if I put x here, and the other side I put y there, right? So we have already swapped. So remember what I told you, since you're working with an exponential, we said that an inverse of an exponential is a logarithm. So to write this in a log form, this is what you should remember. There's a manner of writing it. It's a log base number is equals to exponent. No? Log base number is equals to exponent when you want to change your exponential to a logarithm function, right? So what am I going to do? I'm going to say log. Where there is base, you put 2. And remember, your base here, guys, no? Your base, it's 2. Remember, this is 2 to the power. We said it's a log base. Our base is 2. What is our number? Our number will be x. So in this case, your base here, it's 2. And x becomes your number. X becomes your number. And this becomes your exponent. Right? So, as we have said that this is log base. What is our base? Base is 2. What is our number? Number is x. So what is our Log base number is supposed to exponent. Our exponent is given as y. So we have already written it in a logarithm form. So we are not done. So therefore f of x is equals to log 2x here, right? So this is the inverse, guys. This is the inverse. I hope I hope you have learned from this. You have grabbed something from this that you are going to use, right? So in terms of finding the inverse of an exponential, right? Then okay, what is another thing? Now let's look at how to sketch. First, we will sketch. If we were to sketch the original equation, remember we have 2 to the power of x, guys. So let's first find your y-intercept, because we can't find an x-intercept in this form. The such exponential form do not have an x-intercept, but we can find the y-intercept. So how do we find the y-intercept? Wherever is x, you replace it by 0. So in other words, if we say 2 to the power of 0, we're going to get y as equals to 1. So in other words, our intercept, it's going to be 0, 1. So we are going to have y-intercepts there, which is 0 and 1. Then, guys, you also need to find other points. In terms of other points, you can use a table method. If you use a table method, let's consider this. Let's say here you're going to have remember, let's say it's 1, 2. It's 1, 2. Okay, let me just write it like this. It's 1 there, then there's 2, 3, and it ends at 4, right? So the other point, let's say it's 1 is to 2. Probably it's another point there, 1 is to 2. Then we also have another point. Let's say that other point, it's negative 1.5. So negative 1.5. So we will then join the points, guys, to draw this graph. To draw the graph, join the points to draw the graph. Yeah, sorry for mine won't be that accurate. It's a reference, so you will use your ruler. Yours should be neat. So this is negative 1.5, 0 and 1, and 1 and 2. Someone might ask, Richard, Mr. Richard, how do we find the inverse? Remember, your first coordinate there, you're given as 0 and 1, right? So the inverse of 0 and 1, it will be 1 and 0. We also have 1 and 2, 1 and 2. The inverse of this will be 2 and 1. You swap the coordinate. This is how you find the inverse for you to draw another graph. Then we have negative 1.5. Since we have negative 1.5, we will swap. So this will be half and negative 1. This is the graph of f of x. And this is the graph of the inverse. This is the graph of the inverse. So let's sketch the new graph. So since we have 0 and 1, here we now have 1 and 0, 0 and 1, 1 and 0, sorry for that, 0, 1, so 1 and 0 should be here. So we're going to say 1 and 0. So what about the other one? Is 2 and 1, so it's gonna be, remember it's 1, then it's 2 here, 2 and 1, 2 and 1 should be somewhere here. So 2 and 1, then we also have half and negative 1. So the half, it should be here, half and negative 1, guys. So it's going to be half and negative 1. Remember here it's 2 and 1. So what do? You join them. Make sure they don't touch the x-axis. Mine, it's rough sketch. Remember, this is y and this is x, right? So we have half and negative 1. Here it's 2 and 1. It's 2 because of space. This should be 2 and 1. Then remember here it's 0 and 1. So 2 and 1. It's here. Sorry for that. Let me write it here. It's 2 and 1. I hope, guys, this is the graph of f, and this is the inverse of, this is the inverse, guys, right? I hope that is clear, right? So now I want us to end our video with how do we determine the domain. Remember the domain, guys. The domain. In terms of the domain of an original graph of f, right, which is y is equal to 2x, will be, remember you did learn that in grade 10, will be x, it's an element of real number. So what about, this is the domain of f of x. What about the domain of the inverse? The domain of the inverse. How will it be that? The domain of an inverse, guys, the domain of an inverse, as we can see, this is where x becomes greater than 0 here. So it will be x is greater than 0. So it's different from the original one. So this will be x is greater than 0. Or you can write it as x is an element of 0 is to infinity. So what about their ranges? Sorry, guys, it's because of space. What about the range? The range of the graph of f, the original graph. In this case, for this graph, we can see that the range will be y is greater than 0. Then what about the range of an inverse? So I say f to the power of negative 1. The range of an inverse. The range of an inverse, guys, it's what we are going to say y. It's an element of real numbers in this case. Or you could say negative, infinity, and infinity. When we are working with an exponential function, so when working with an exponential function, we said that, to recap, we said that inverse of an exponential, it's a logarithm. We said inverse of an exponential is a logarithm, and inverse of a logarithm it's an exponential, right? It's an exponential, right? So it is important to know that the range of the inverse also swap. They also swap. Yes, they are opposite to the original. It's very important to note that, guys. So if I was given this as let's say they said log 2x. Let's say they said f of x is equals to log 2x. Then they said, let me find the inverse. And they said, find the inverse. Remember, I told you that replace by y here. So you're going to say log 2 and x there. So you swap. Where there is y, you replace it by x. And where there is x, you replace it by y. So you then ask yourself, what is the inverse of a logarithm? We said that the inverse of a logarithm is a what? It's an exponential. The inverse of a logarithm is a what? It's an exponential. So from that, you can write this as an exponential. Remember, an exponential is made up of base. What is your base? Your base is 2. And what is your exponent there? Your exponent will be x, right? So this will be 2 to the power of x. Then your number will be y. So this will be your inverse. It's an opposite, right, guys? So I did show you how to work with this. I hope guys have shed some light, even though there were a lot of notes written here, but I hope you have learned. See you on the next one, where we will be looking at the inverse of a straight line, right? Remember, inverse of a logarithm, it's an exponential. The inverse of a exponential, it's a logarithm. Well, if you're new to this channel, what are you waiting for? Kindly subscribe. We are growing as a community, and remember guys, we love you.